All right, hi, I'm Marissa Montgomery. I'm a software engineer at Spoke, and today I'm going to talk about how we built our chatbot. So the title of this talk is Multi-Channel Distributed Chatbots on MongoDB. Multi-channel here meaning we serve multiple channels. So we currently have Slack and SMS. Distributed meaning our chatbot scales to multiple servers from the start. And of course, we built this on MongoDB. So a little bit about our company, Spoke. We're a business-to-business software as a service company based out of San Francisco. We're building a workplace ticketing system similar to Zendesk or Jira. And our workplace ticketing system incorporates AI. So you can make workplace requests like, what's the vacation policy? And we'll either try to route it to a team that we think can help, or we'll automatically resolve your request for you with resources from our knowledge base. So when Spoke started 2 years ago, a chatbot was one of the first things we broke ground on. With our bot, you can make a request using Slack, SMS, or email. Spoke will route it to the right team. So here we have, for example, sales, legal, or design. And we'll also try to route it to the right person if possible. When an expert answers, meaning someone on your team knows the answer to your workplace request, Spoke will learn from that so that next time the bot will be able to give the right answer without any human intervention. So here's an example of what it looks like in Slack. Here we have Rochelle asked, what's the guest Wi-Fi password? In this case, the bot found a resource for the Wi-Fi password, surfaces it and asks, did that help? Rochelle says yes, and the bot says great. Here's what a similar conversation would look like in SMS. And here's what it would look like in email. So over email, we don't actually send multiple emails for each step of the conversation, but we provide a link back to our web app where you can give feedback. So there are a few main questions that we thought about when building our chatbot. And the first was, how do we keep track of conversation state between responses? So one of the core things about chatbots is that they remember what you said previously so they can intelligently respond the next time. The second question is, how do we maintain a similar look and feel through such different channels? So we want to have the same bot logic, but also be able to take advantage of Slack's rich formatting, for example. And we can send images, stuff like that. And the third main question that we spent a lot of time talking about is, what does a chat session mean? So chat sessions are how we represent a single conversation with the bot. And for this, we had to think about, especially, what does a unique chat session mean? And for that, we set up MongoDB indexes that I'll get to later. So first, just an overview of our conversation flow. And there's two main types of conversations that our Spoke bot can have with the user. The first is auto-resolving. So as I said, this is, say the user asks something like, what's our vacation policy? And the bot surfaces a resource that says all of our holidays for the year. That would auto-resolve the user's request. The second example is for workplace requests that might involve more work from another employee, such as, my laptop broke, can I get a new one? Maybe an employee needs to set up a new laptop for them. And this would create a service request in our system so we could track that work. Here's a high-level view of what's actually happening when we receive a message through our bot. And I won't refer back to this graph much, but it's just to kind of see bird's eye view what's happening. So we have our two channels, Slack and SMS. We receive a message. We'll save that data. We'll create a new chat session model, save it to MongoDB, our database, and then we'll incrementally save updates on the chat session and then respond through the appropriate channels. Oops. So those are supposed to be emojis, but say a new message is received. We have our two channels, Slack and SMS. Through Slack, we receive messages through an RTM WebSocket, so real-time messaging. And through SMS, we receive messages a very different way through a Twilio webhook. So if you're not familiar with Twilio, it's a third-party service where you can purchase phone numbers, and you can set up a webhook such that when a message is sent to your phone number, it'll hit your webhook. So the second step is that we either create a new session or we look up an existing session. So if this is the first step in a conversation, we'll create a new session, but if it's the second or third step, we'll create a new session. We'll look up an existing session. The third step is to determine the replies that we're going to send back. And we have a module called Bot Engine that takes care of determining our replies, which I'll get to later. As a fourth step, we save the updates on the chat session. We'll actually release the lock that we acquired at the beginning. And as a last step, we'll respond through the appropriate channels. So for version 1, we wanted to create a multi-step conversation flow. So the basic building blocks of a chatbot have it have multiple steps. Our main two goals here were to fluidly handle multi-step conversations and to only respond once even when scaled to multiple servers. So we wanted to make sure our operations were atomic from the start, so we're not playing catch-up later when we scale. So diving into keeping track of conversation state. So a lot of chatbots have this concept of a callback map, and this stores information about the bot's response strategy, and it essentially maps a user's intent with an action that the bot should take. So this can be in mapping a pattern to an action. So for example, if the bot asks a question, did that help? So say the user makes a workplace request, the bot surfaces a resource and asks, did that help? If the user says yes, we want to count that resource as accepted. So now that we know that we need a callback map for our bot, the next question we asked ourselves was, do we want to use a third-party callback map, or do we want to build out our own? So in considering this question, we looked at how BotKit implements callback maps. So BotKit has the concept of convo, which is similar to our chat session, and they have the method add question. So when your bot is asking a question, you can set an array of callbacks that will provide actions. So there were a lot of things we liked about BotKit's implementation, but we ultimately decided to roll out our own callback map for these two reasons. The first is that we needed to hold information about our conversation state in a framework agnostic way. So right now we have 2 to 3 channels. While BotKit does support a lot of channels like Microsoft Teams, we want to be able to expand to other channels that BotKit might not support. The second reason was we wanted a default action that we could specify according to the question that was asked. So if the bot asks, did that help? If we don't understand what the user is saying, we actually want to fall back to an action that the bot takes. So this is what our callback map ended up looking like. So as I said before, we have our default action and, similar to BotKit's, an array of callbacks. Callbacks include a pattern and an action, and the pattern is actually a keyword that maps to a regex in our code, so we're not storing the full regex. And the action will also be a keyword that maps to a path for the bot to take. And here's a screenshot of what it looks like in the database. You can see it's pretty easy, pretty readable that we have the keywords in here. And we have our default action, which is to assign a request if we're not understanding what the user is saying, if it doesn't fall into one of these two patterns, yes and no. So that kind of solves our first question. How do we keep track of conversation state? We want to do a first-party callback map, and we want to specify default action in case our regexes don't cover all possible user responses. The next thing we thought about is indexing and atomic operations for multiple servers. So how do we build this to scale from the start? we wanted to create a unique index on sender and channel. So sender here is the user that's sending us the message, and channel could be Slack or SMS. One important thing to note here is that all messages that are sent to us through Slack currently go through our RTM, and we don't have a load balancer for that. So all of our, at this moment, so all of our servers would actually receive the message at the same time. So being able to do this database level locking was really helpful to us to make sure that we don't have multiple servers responding at once. And this is a unique index, as you can see, the unique true at the bottom, meaning you can't have two chat sessions at the same time with these, with the same sender ID and channel ID. So this starts to define our third question of what does a chat session mean. First, we're going to say it's unique on sender and channel. For version 2, we really wanted to double down on Slack as a channel and do some deeper integration with them. There are 3 goals here. We wanted to be able to format bot responses differently per channel. So as I said before, we wanted to keep the same kind of core bot logic and just format the responses differently. The second goal is that the user should be able to both DM the bot and message it in a public channel. Channel here meaning actually a Slack channel. So if you're familiar with Slack, they have public channels and DMs. And we thought it was really important to include this so that, say if a user was giving a demo of our bot in a public channel, but also wanted to DM in a private channel, they should be able to do that. And the third goal here is that if a message reaches our second server after the first server has already responded and unlocked the session again, the second server should not respond. So going into channel-specific formatting, and just for some context, we have our chat session data model, and we actually have updates as an array subdocument within our chat sessions. So updates are how we represent messages either from the user or from the bot, and any changes that happen on our request. So we actually have this concept of, so our main bot module, bot engine, is actually an abstract base class. And we have these 2 concrete subclasses called Slack bot and SMS bot. The first method we overrode here was get channel formatted replies. So we're not changing a lot of the actually content of the message, but just the format. So get channel formatted replies can format any updates into either a Slack response or an SMS response. So here's what the same message would look like in Slack versus SMS. So this is the message that the bot sends back when you ask for what's our holiday policy. On the left, you can see we take advantage of rich formatting. We can send the image of the team that it's associated with, send the color, and more data about what our holidays are. And on the right, we kind of condense it. Because it's a text, we don't want to send you multiple texts. And these are, the only difference between these are the output of that get channel formatted method. So this answers our second question. How do you maintain a similar look and feel through such different channels? And the answer was having subclasses so we can format responses differently and being able to convert updates into these responses. So now being able to message in a public channel and DM the bot at the same time. And for this, we had to add to our index again. And there was one more field that we needed. This field is called receiver ID. So for Slack, this is actually the Slack channel ID. So this let us do database level locking and make it so you can have multiple channels, or sorry, multiple chat sessions for the same sender and channel as long as they're on different Slack channels. So for SMS, each Each org, which is how we represent companies, has a unique phone number associated to them. So this is the receiver ID for SMS, and as I said for Slack, it's the Slack channel ID. Private DMs will have different channel IDs than public DMs. Another benefit of storing the receiver ID is that we're now able to @mention the user in public channels. So now that we have the ability for multiple users in a public channel to be interacting with the bot at the same time, we don't want it to get too noisy, and we want to make it clear who the bot is responding to. So this adds to our third question. A chat session should be unique on sender, channel, and receiver. Next, we found a bug where the bot was responding twice. So looking at this scenario, we have a message coming in from Slack through our RTM, and we have 2 servers. So the message will hit server 1 in the expected case, and then hit server 2. But it's actually possible that the message could hit server 1 could respond, and at this point we have server 1 has created a new chat session, locked it, responded, and then unlocked. And so what would happen next is that server 2 would try to pick up that same chat session and treat message 1 as a new message. So this could be pretty confusing for users. And the solution was to add again to our initial index and add this field previous message IDs. So one of the cool things we could do with MongoDB is actually add an array of items as a unique field on our index. Of course, these message IDs had to be unique. For SMS, Twilio guarantees a unique message ID. And for Slack, Slack actually uses the timestamp, which is unique per Slack channel. So this guarantees that we're not going to have a chat session at any time with the same previous message IDs and the same sender, receiver, and channel. So in that case, actually, server 2 would not reuse the same chat session, but would fail to acquire a lock. So for version 3, we started thinking about the lifespan of a chat session. So now that we have these conversations, we don't want them to go on for forever if the user doesn't answer. So say the user asks us a question, we respond and ask, did that help? And then the user forgets about it and comes back the next day and tries to ask another question. We don't want to treat that as a continuation of the same conversation. So there are 2 goals in thinking about this. The first is that we should persist the chat session so we can use data from it later, but time it out after 5 minutes. So we won't try to pick up the chat session again after, if it's been 5 minutes since the user responded. The second goal here is to be able to edit past messages with a session. So now that if we're going to store the session forever, then we want to be able to make updates to it past this 5 minutes, but not have it be a part of the same conversation, essentially. So thinking about how chat sessions should time out after 5 minutes. And there's 4 possible user scenarios for our users to interact with our bot. The first scenario is the user asks a question, the bot responds and asks, did that help? And the user can give us immediate feedback and say, yes, that helped. The second scenario is that the user could immediately respond with another question. The third scenario is that the user could give us feedback, but maybe after 5 or 10 minutes. So it's possible they could be reading through the resource that we sent them, and they don't have feedback until a certain amount of time has passed. Or after 5 to 10 minutes, they might ask us another question. So we found that it's pretty rare that this case would happen, that after 5 to 10 minutes, the user would actually give us feedback. It'd be much more likely that they would ask another question. So this is how we got to our 5 minutes threshold. So So we decided we wanted to expire chat sessions after 5 minutes, meaning not try to reopen them again. Now that we had this threshold, our next question was, do we want to delete these sessions completely from the database, or do we want to keep them around and assign a status like closed? So we first looked at a MongoDB Ttl Index. Here's just a bit of a summary about it. It's a single field index, and this field can either be a date or an array that contains date values. And you specified the amount of time that you want the index to expire the document after, with this field expire after seconds. So with chat sessions, you can basically say after 5 minutes, at the database level, expire this document if it hasn't been updated in that time. So here's what our TTL index looked like. Here we have our single field, last updated at, which is a date, and expire after seconds, 300, which is this 5 minutes threshold. And this worked really well for us for about a year. We could trust that these documents would get expired after 5 minutes, and we wouldn't have that problem with the chatbot trying to pick up a conversation after a day or two. So after about a year, we decided that we wanted to start keeping these sessions around. So we used a cron job to mark sessions that haven't been updated in 5 minutes as closed. The caveat with this is that our cron job would run once a minute. So sessions would actually get expired within 5 to 6 minutes. Now that we're keeping these sessions around, we had an interesting problem that I'll get to later. And just I'm going to define what a partial index is first, so you have some context when we get to that part. So a partial index is pretty interesting because it lets you specify a constraint or an index on only a subsection of your collection, essentially. And it's based on the filter expression that you specify. So in our case, we want to start creating a unique constraint on only chat sessions that were open. And just some more details, it supports equals, exists true, greater than, less than, and at the top level. So you can see our original index on the left, and we actually created a new index on the right, which is a partial index. And you might be able to spot the difference. On the right, on the left, we have previous message IDs, and we omit that from the right, but our second index is only for open sessions, and I'll explain that scenario. So say we have 2 messages coming from Slack and 2 servers. It's possible that message 1 could go to server 1, and message 2 could go to server 2. The result here would be that 2 chat sessions are created. This is because if you look at our initial index on the left, they have different previous message IDs. So the database will actually treat them as unique. Now that we have this new index, in this scenario, actually, only 1 chat session will be created. And this is because we specify on the right that for open chat sessions only, they have to be unique on sender, receiver, and channel. And on the left, we have this previous message IDs constraint for all chat sessions. So we wouldn't have this scenario anymore where there would be 2 chat sessions open for the same sender, receiver, and channel, even if the previous message IDs are different. So this further defines our third question of what does a chat session mean. And now we want to say only open sessions are unique on sender, channel, and receiver. Because we're keeping chat sessions around, we could have a lot of expired chat sessions laying around, and we don't want to, but we want to make sure there's only 1 for open sessions. Storing these chat sessions let us take advantage of some Slack interactive features. So here's one feature we have. So this is pretty similar to the conversation we saw before. Someone's asking, when is the all hands? Spoke asked, should I try to find someone who might know the answer to that? The user says yes, and a request is created. If you notice now we have these two buttons at the bottom. So we have the option to either cancel the request. Maybe the user made this request by accident, said yes instead of no. Or we have the option to, to file this under a team. So say I have this request made, but I want to help Spoke out a little bit, and I want to say, this is actually having to do with office management. I can select office management from the drop-down. It'll file it under the team and auto-assign it to a person. But the interesting thing here is that this chat session could have been more than 5 minutes in the future. But because we're keeping chat sessions around, we have the data that we need to be able to make an API call to Slack to update this message. So this is the last piece of our what does a chat session mean question. We want to persist this for later use. So some next steps for the chat session data model. Because we're using this database level locking and we have unique indexes set up, we think it'll be pretty natural to introduce sharding. And of course, we want to expand to other integrations besides Slack and SMS. And just to recap our questions, how do we keep track of conversation state? We built out our own callback map with a default action that we store on MongoDB. How do we maintain a similar look and feel through such different channels? We use subclasses to format the message, and we have this update subdoc on our chat sessions that we kind of use as a common format. And third, what does a chat session mean? Open sessions, there should only be one open session at a time per sender, receiver, and channel, and we should persist it for later use. And here's a last look at our indexes that we ended up with. And I'll include this when these slides are posted on the website. So thank you. We probably have a few minutes for a Q&A.
Oh, thank you, Marissa. And anyone, any questions? We have one? Here we go.
Toward the end there, when you said 5 minutes in the future, did you mean 5 minutes in the past?
Sorry, what was the sentence I said?
About messages that you wanted to do something with.
Yes, we want to expire chat sessions if they haven't been updated in at least 5 minutes. So if they're updated more than 5 minutes in the past, you want to expire them. Does that answer your question?
Yeah, thank you.
Great.
Thank you. When you mentioned locking out the servers between like server 1 and 2, is that a nature of how you guys built the service, or is it because you're using Twilio and multiple other services?
Oh, sorry, which?
In terms of, we have this problem of like if we have multiple servers, like it was like server 1, server 2, and you get an answer, and then like one answer is locks out, locks in. Is that because of how the system was built, or because of all the services that you're trying to integrate across channels?
Yeah, so it's pretty much because of all the services, because we have this RTM channel that we don't currently have load balancing in front of, then all messages go to all servers. And because we actually have load balancing for our web server, so we have load balancing for our Slack channel, SMS channel integration, but not for Slack.